looking at how the ratio test works, we're going to use it to determine whether the series, the sum as n goes from 1 to infinity of negative 2 to the n over n squared, is convergent or divergent. First thing we do, we write down the limit as n approaches infinity. And now what I want is the absolute value of a sub n plus 1 over a sub n. Substituting n plus 1 in place of n, we get negative 2 to the n plus 1 divided by n plus 1, the quantity squared, divided by, now a sub n is negative 2 to the n divided by n squared. This isn't an absolute value, and so I didn't actually have to write down the negative. I just really did it for your benefit. The way I'm going to start to compute this, though, is we are dividing by a fraction. And so I'm going to flip the denominator and multiply. We have the limit as n approaches infinity of 2 to the n plus 1, now I've dropped the negative, divided by n plus 1, the quantity squared, times the reciprocal of the denominator, n squared, divided by 2 to the n. It got lost there because I was about to tell you I wrote the absolute value, but I didn't need to. So at this point, I'm dropping the absolute value symbols. We've just applied the absolute values by not writing the base of negative 2. Now inside these parentheses, if I have n plus 1 factors of 2 in the numerator, but n factors of 2 in the denominator, then 2 to the n divides out. I then have the limit as n approaches infinity of 2n squared divided by n plus 1, the quantity squared. But dividing now by the largest power of n that appears in the denominator, in both the numerator and or dividing both the numerator and denominator, I mean to say, we get that the limit as n approaches infinity is now acting on 2 over 1 plus 1 over n, the quantity squared. In the denominator, that 1 over n, as n goes to infinity, is going to become 0. And this limit is equal to 2. Actually, I'm going to put that down here so that I can say, and 2 is bigger than 1. So this is not like the limit comparison test. I don't just say, oh, it's finite, so we're good to go. It's less than 1, it's greater than 1. And I need that to be the case to draw a conclusion using the ratio test. So the series is divergent by the ratio test. That was so fun. Let's do another one. It's the sum as n goes from 1 to infinity of n to the 10th divided by negative 10 to the n plus 1. I'm going to skip 2 steps this time. I know. It's the limit as n approaches infinity. Look, we know we're going to drop the negative 10 base. We're going to use the absolute values. We also know we're going to end up with a fraction divided by a fraction, so I might as well flip it out and multiply to begin with. So I've got the limit as n approaches infinity of n plus 1 to the 10th power divided by 10 to the n plus 2. That's what happens when I plug in n plus 1 in place of n, times the reciprocal of what would be the denominator, so 10 to the n plus 1 divided by n to the 10. Now, I have n plus 1 factors of 10 in the numerator. I have n plus 2 factors of 10 in the denominator. That means there's one more factor of 10 in the denominator, and so 10 to the n plus 1 divides out, leaving me with one factor of 10 in the denominator. That then becomes the limit as n approaches infinity of n plus 1 to the 10th power divided by 10 times n to the 10th. Dividing numerator and denominator by the largest power of n that appears in the denominator, we get this is the limit as n approaches infinity of of 1 plus 1 over n whole thing to the 10th power divided by 10 in the denominator. As n approaches infinity, 1 over n goes to 0, leaving us with a limit that has a value of 1/10, which is, guess what? Less than 1. The ratio test gives us absolute convergence, so the series is absolutely convergent by the ratio test. And my answer here underscores something that's kind of important. At this point now, you've seen something called absolute convergence and something called conditional convergence. Now, when you have an alternating series, if you say that it's convergent, you got to tell me if it's absolute or conditional. Thankfully, the ratio test gives us absolute convergence, and so we're done there.